Notice the book's closed. To say that I do things my way would probably be an understatement, wouldn't it, guys? Those of you that have had me. I don't feel any obligation whatsoever to do things as they are in the book. It's my considered opinion at this late date in my life that most mathematicians, particularly the kinds that write textbooks, are pompous asses, and that they are more interested in impressing their colleagues than they are in explaining it to you as the easiest and most straightforward manner possible. I have different goals than that, and I'm going to do it my way. As I used to tell my teenage sons, this is not Burger King. You do not get to have it your way. I'm going to have it my way. And I think you'll like my way better in most cases. I'm not out to cover everything in a very formal manner. I'm out to cover everything in a manner that you understand and that it makes sense to you. Calculus from here on is way too complex. Way too complex to memorize. You can't do it. You can't memorize. I know some of you are young and have excellent memories, and you got through school with little effort and memorizing things and got by. Can't do it. Can't do it. Wait until you see chapter 8 in this course. There is no memorizing in chapter 8. You got to understand, and that's my goal. I go for understanding. I want you to understand what I'm doing. And that's why I stop so often and say, don't let me go on if you don't understand. Okay? So, stop me. Stop me. This is what Smart Notebook looks like. I believe Ms. Hardy used it. For those of you that had her, there's still one or two of you that had me for Cal 1 and or other classes, and you're accustomed to it. I'll show you tomorrow how to log in and all of that. Let me tell you this, the login procedure has changed. You can't log in you can't go to coursecompass.com like you did in Cal 1. It works the same way. You don't have to pay any additional money, but the login procedure is a little bit different. It's in that handout, and you can do it. It's a different site, and your password is the password that you use to get in on Blackboard. And again, I trust that you can read. If you have any troubles, let me know. I'll also talk next week about the engineering help lab. Dr. Thomas will probably be in a minute, that Dr. Thomas does, and I'll give him a chance to talk about it when he comes in. Okay? Let's get going. This is chapter 5. XY grid, and if I wanted to find, say, for those of you that had it before, would it be safe to say that I am not the best artist in the world, and I don't try to be? I try to be the best calculus teacher I can. Can you find the area between those blue lines and the positive x-axis? Can you? Yes or no?
Yeah. Yes.
Of course you can. This point, I think you'd agree, is the point 3, 2, isn't it? And I think you learned that the area is equal to the length times the width, which is equal to 2, well, 3. 3 times 2, which is 6. So all we did is we took that rectangle that you first saw in what, the 3rd or 4th grade, and put it on the XY grid, didn't we? Okay. Now, how about this? I'm getting rusty. There it is. Well, I wasn't counting on that. I'm gonna get tired of this in a minute. No, I don't want to do that.
The green.
Yeah, if you pivot the green.
I want it to go the other way. It says flip left and right. That's the way I want to do it. I want to. Yay! Let me get that out. Can you find that area? If I take this and if I put it right there, I wish it were another color. And let's say that it is up 4 and down 4, huh? Let's say that this point is the point 4, 0, and this is the point 0, 4. Can you find the area of that rectangle, that triangle? Of course you can. You'd use the area is equal to 1/2 the base times the height, or you just find the area of the rectangle of the square, a 4x4 square, which is 16, and take half of it, right? So you can find that one. Enough of this. Now I want to go to this situation. I want to know, this is the point. When I think I'm making a dot on one of those points, it doesn't appear that way up here. This is the point 1, 1. I frequently do this. As long as I hold the pencil, I can make those tick marks be anything I want them to be, right? The first one doesn't have to be 1. I can mark off 4 to the right and say that's 1, can't I? But what I have to do is tell you which scale I'm using. I get to do it my way. I get to mark it off the way I want to, as long as I tell you that it takes 4 tick marks to make 1 instead of 1 tick mark to make 1. Do you agree?
Right.
Now, what I want is I want the area, I want the area this area. And I do it up there, but I can't get to those tips up there. You get the idea, don't you? Can you tell me what that area is? The answer is no. Because it's not a rectangle, it's not a square, it's not a trapezoid, it's not a circle. All of those things, you could tell me what the area was, right? But you will find that in engineering, it's not about the squares, the rectangles, the circles, and the trapezoids. It's about funny shaped areas. Way worse than that one. It's about whatever you're doing. Have any of you seen the Golden Gate Bridge? The Golden Gate Bridge, you know those cables? Those cables on the Golden Gate Bridge look like that, don't they? And were you designing the Golden Gate Bridge, you would first draw them out and decide that it would work to do that. And where I'm headed is things in real life that you'll be doing in engineering aren't in neat packages. And I've got to show you a way to handle something like that. And the way we're going to handle it is real simply. Real simply. So every hash mark on both the X and Y axis is how long between hash marks? A quarter, 1/4, 0.25, huh? If the fourth hash mark's 1, then each mark is 0.25, huh? So given that I don't know how to do that, I'm going to do it just real simple. We're just going to keep it simple, and we're going to do this. What we're going to do is, I'm going to break that up into little bitty, come on now. I do have yellow. I need to get up in there because I'm going to talk about this. Okay, good. I'm going to break that up into little bitty rectangles. And I'm going to start, I want to know the area under the curve, y equal x squared. That's that graph, isn't it? Y equal x squared. And in quadrant 1. Isn't that a lazy way of saying that above the x-axis and to the right of the y-axis? I just say both of them at the same time, don't I, when I say in quadrant 1? Yeah. Okay, and do we all agree that's the yellow area? Everybody agree?
Yeah.
Now here's what I'm going to do. I'm going to start with, I'm going to break that up into 2 rectangles. Do you see the rectangles? And what I'm going to do now is I'm going to find the area of each rectangle. And I'm going to use that as an estimate. Do you see the obvious problem with that? What is it? It's not going to be so all fired hot, is it? And that is, do agree with me? Is your impression the same as mine, that this area in each case is the error in our approximation? Do you agree? And that's bad. In this case, it's awful. Would you not say?
Pretty big.
Is the area that I get by adding these two rectangles, is the area that I get going to be too high or too low?
Way too high.
Way too high, right? Does everybody agree? So I'm going to say, how about this? Suppose I call it the area H. I'll make it little h. Hi, Ed, come in. The area H is equal to R1 plus R2. I'll bet you know what R1 and R2 are, right? The two rectangles. So, is it all right if I say that the area of R1 is equal to 1 times 2, and the area of R2 is 2 times 4? Is it okay if I say that?
Yes, you could, but I thought we were dealing with quarters.
We hadn't gone to quarters yet. I'm just breaking it into two parts.
Oh, okay. I'm with you.
Everybody agree? And is that not, let's see, that's 8, and that's 2. Is that looking like 10 to you? So what I know now that I didn't know before is that yellow area that I'm looking for is going to be less than 10. Do you agree? Okay. I'm going to stop a minute, introduce Dr. Thomas. Ed, come up here.
Okay.
This is Dr. Thomas from the math department. Dr. Thomas is a good guy. And the math department is investing some precious money. You know what's going on in higher education in the state. Some precious money to pay Dr. Thomas to run an engineering study hall here on campus. Dr. Thomas has a PhD in chemistry, but his undergraduate degree is in engineering
Science.
What?
Engineering science from
Engineering science.
electrical engineering option.
And he can help you in all of the calculus series. Most of
One, 2, and 3. For the time being, I've had health issues that
most especially Cal 2, and physics courses, engineering courses, chemistry. He can help you with any of those. And we're working out the details of when he will set up in a relatively small room with a computer, or with computers, where you can come in and ask him questions about any of those subjects. We'll have the computers to where if you have a homework problem that you can't work, you can come in and call it up on the computer, and Dr. Thomas will help you work on it. It's a real good benefit, but it's more than that. Dr. Thomas is a good guy, and he cares. And he doesn't limit himself until to just the time that he gets paid. He, like I, am available to you anytime we're on campus. So if you have a problem, and just come around to the math department and look for either one of the two of us, and we'll stop what we're doing and help you. It's a huge benefit. Get to know Dr. Thomas and let him help you. He wants to.
Well, I took Cal 1 from Mr. Scott about 3 years ago. I took Cal 2 and Cal 3 from you in the last 2 years. Maybe an A in all of them, plus electronics. I've been in that. All you E majors, if you don't know electronic circuits at the practical level, I advise you take electronics with Mr. Pratt. You don't want your technician to know more about the circuits than you do.
Okay, I just want you to meet Dr. Thomas. He'll be coming in most days and just come in and sit down. I've offered him the option, if he finds something he wants to, a portion of Cal 2 that he'd like to present to you. He has that standing invitation also, but he has a class.
From 8 to 8:50.
Yeah, so that's why he'll be coming in like
And some advice, the first test, don't mess up on the first test and here and say, you'll do better, I'll do better on the second. I said, no, you won't.
This is real math. That's all I can say. This is real math. Don't underestimate it. I've been told before that doing stuff like this, I make it look too easy, and that I lull students into a false sense of security, and you get the wake-up call on test 1. There are no drop tests in this class. You own them and live with them all, and you don't get to mess one up, because they're still students that go all the way through Cal 4 that say the 4th test in Cal 2 is the hardest test they've ever seen. And Dr. Thomas said that about it.
Well, I made 96 on it.
Yeah. Okay. So now we know that that area is less than 10, right? All right. Now we're going to play with it some more. Let's see how I can do this. I don't want to copy that. Don't start that stuff. That's what I want. Now what we're going to do is this. Same yellow area. Oops. Dadgummit. I did it again. I won't do it this. Same yellow area, right? Only this time I'm going to build a rectangle starting from the left side, from here over to here. And another rectangle starting from the left side, from here over to here. So let's compare. I wish I had them on the same page. Do you notice that what I did is I built 2 rectangles, didn't I? Right? This time I started from the left end point of the rectangle and went over to the right. Is that right? And on this one, this rectangle we call R2, I started from the left end point, whoops, I say whoops, the left end point, and I went over to the right. Everybody agree? And this is, that's Miss Hardy's kind of colors right there. this is R2. And R1 gets a little bit hard to draw, doesn't it? Would you say? But for right now, all I want you to notice is how I made it. I went to the left end point and drew a line straight over, and I did the same thing right here. Okay? Whereas before, I want you to notice, I went to the right end point of the rectangle and drew a line back to the left. Okay? Now, look at the difference. Look at the difference. Where do you find the error in this approximation? The yellow above the blue lines, is that right? Is this and this the error? Would you agree? Everybody agree? Okay. Further, would you agree that the area is equal to R1 plus R2? But the problem with R1, the length, let me identify that point again. The length, what's wrong with the way I did that? It just hit me. Jeez, and you let me get away with it. And this is the first one. The length of R1 is from here to here, right?
Right.
What is that distance?
1/2.
1/2. Do you see what I did? I just started counting off tick marks. And you let me get away with it because you did the same thing, right? But remember, this is 1, huh? So half of 1 would have to be 1/2, huh? Everybody agree? So, doesn't change so much, but we'll get it right. And that is, this is equal to the length times the width plus the length times the width, which is equal to 1 times 1/2 plus, now I get 4 times 1/2. Not 4. What?
1.
1.
Wouldn't the other one be 1/4?
Say what?
1/4 times 1/2, the first one.
It is. 1/2 there, and this is 1/4, isn't it? Is that right?
It is.
When you get old, you have to do things like that. Just mark them on there. Okay? Everybody follow what we did wrong a minute ago? And this is 1/8 plus 1/2. 1/2 is 4/8, right? 1/8 plus 4/8 is 5/8. And that's still the upper bound. That is the everybody okay with that? Now over here, this one is equal to length times the width. The length is 1/2, but the width is what?
0.
0. Do you agree? And then this one, the second one is, the length is 1/2, but the width is what?
4 is a quarter.
A quarter, 1/4. Everybody agree? So now I have 0 plus 1/8 or 1/8. So, and this would be the lower bound. So now our area, which is the real area, is greater than what? 1/8, and is less than 5/8. That's not a lot of help, but it's more than we knew to begin with, right? Everybody agree? But our goal has to be to shrink this purple. To shrink the purple. That purple is way too big. Do you agree? How would you shrink it? Do what?
Add more rectangles.
Exactly. Add more rectangles. Do we agree? Everybody? So, let's do that. Let's do that. Isn't that what you told me? So, here we go again. This time, what we're going to do, and we're going to do it a little bit faster, is we're going to do 4 rectangles instead of 2. And I'm going to do them from the right first again. So watch what happens. Now I have this rectangle going. Then I have this rectangle. Then I have this rectangle. I'm off. 1, 2. No, I'm all right. And then I have this rectangle. Do you agree, everybody? 4 rectangles? And we're still interested in the yellow area? is going to be that. Do you agree? And wouldn't you say that's a lot better than what we had before? Everybody agree? So let's see if we can do the area for the high side or the upper bound is equal to R1 plus R2 plus R3 plus R4. R1, start at the left, huh? R1 is equal to length times width, right? What about length times width? What about length times width? Well, the length is 1/4, huh? I need to know though, don't I need to know this height right here?
Would it be a quarter squared? A quarter squared?
This is a quarter all the way across, and yes, it would indeed be. This point right here is a point X and Y. Do you agree? Everything on the grid is X and Y, isn't it? And you know X, don't you? The X value of that point is 1/4. Does everybody understand why the X value of that point's 1/4? Because every tick mark's 1/4, and it's on the first tick mark, right? How do you find a Y value? Well, this curve is Y equal X squared. So wouldn't the Y value be 1/16? Does everybody agree? If you don't shake your head, I call on you. Does everybody agree? If you don't want to be called on, shake your head. Okay? Okay. So, isn't X the length and Y the width? Huh? So, isn't that then 1/4 times 1/16? Then R2 is length times the width. But have you figured out that the length is going to be the same every time? Does everybody agree with that?
Yes. Yeah.
Because we broke it up into equal parts. Okay, so that's 1/4 times, but now I need to know the coordinates of that point. And the X value is 1/4. Whoops. The X value is what? 1/2. Is that right? And the Y value would be 1/4 because you take whatever X is and square it. Everybody agree? Everybody follow? So isn't this 1/4 times 1? It was 1/4 times 1/4. Let's see if that's right. It's not 1/2 because 1/2 is this distance, is it not? And our little rectangle right here is just one block, right? Not 2 blocks. Everybody agree? So that's why it's 1/4 up there, okay? And the height, I'm sorry, the width is wherever that point is, right? And that is, and you get that by taking 1/2 and putting it in for x in the original equation and getting the height of it. Everybody okay with that? Okay? Then, now I need, not that point. I need this point, right here. I want you to notice something. Tell me if you think I'm right. Did you see what I did? Did everybody see what I did? Camera won't get it, but what I did is I put a little pink dot right there. Doesn't that represent an error where the rectangle and the curve don't match? Is that right? Okay? I just want you to remember that because we're going to use it on Wednesday of next week. I need to know then the x value of that point. This, no. Miss Hardy's going to give me a hard time about writing in pink, can you? This is that 3/4? 1, 2, 3, 4. Is that right? And then 3/4 squared is 9/16. Is that right? Get the idea? Everybody?
Yes.
So now then this one is 1/4 because they're all, it stays the same. And that's a plus, isn't it? Times 9/16. Is that right? Everybody? Okay, now the last one. Why did I not need to bother with parentheses?
Because it's being added.
Yeah, it's because Aunt Sally said don't worry about it, right? Do you know do you remember about Aunt Sally? You do multiplication before you do addition.
Why is it 9/16?
Hmm?
Why is it 9/16?
I do, where did I get it?
Where did it come from?
This is x, right?
Right.
So I put x equal 3/4 up there. And if I square 3/4, what do I get?
9/16.
That's where. All I'm doing is
You're getting the point.
Yes.
Okay, I was doing measurements.
I substitute 3/4 in y equal x squared.
If it's at 9/16 and it's going off the curve to the left, then we wouldn't have the error, the pink error under the line.
Well, what I'm about to do, you wouldn't have the error under the line?
That little
You
pink
wouldn't have that error?
No, to the right, the little dot that you drew.
Oh, that little dot.
Yes, sir.
Doesn't this rectangle cover everything here?
Yeah.
Huh? And this much is error, obviously, but isn't this area that's under the red line, but not under the black line?
If we're doing 3/4 and 1/2, but we're doing 9/16.
9/16 is on the curve.
Yeah, it's going off the curve to the left, right?
9/16 just gives me,
The point. That's,
9/16 just gives me the height of
Why not?
9/16 gives me,
For first day.
The height. Hey Jay, you sure you business administration?
It's not statistics, it's the intersection of that black line and the red line.
yeah, 9/16 is the intersection of the black line and the red line, all right.
That'd cover the whole area of that red line.
So the
Would
top
be the area.
of that rectangle would be a little bit higher and not cover that.
The height would be 1/2.
You're right.
Would it be like this?
Let me say it again. Let me say it for the camera. You're right. Only that is still going to be an error. But for right now, that R3 is everything from here down, right? And I'm not gonna notice that just yet. I'm gonna notice it when I get to R4. And let me show you what I'm talking about when I get to R4, okay? You're right. The R3 up there, does everybody agree, is that area?
Yes.
And therefore, this dot doesn't enter into it right now.
Okay.
It's about to in a minute, but not right now. Okay? You are correct. And thank you.
Yeah, thanks for giving me.
Everybody all right with what we've done so far? Now what we're going to do, we got to do R4. And R4, that's 1/4 again. And it is, I'm looking for that point right there. But is that 1/1?
Yes.
That's 1/1. So I have 1/4 times 1. Do we agree? Everybody? But now look what happens. This R4 is this rectangle right here. This much is too much. Do you agree? But this little dot gets left out because it's not in R3, as you pointed out, but it's not in R4 either. So that little bitty area right there is not in any of my rectangles, but yet it's under the red line. Follow?
Wouldn't it be in R3 because the 9/16 is going off the curb to the left?
Isn't that bottom corner of that square?
It's above R3 and to the left.
Yeah, it's above this one. If this is 1, 2, 3, 4, right here, 3, 4.
It's drawn as it's above.
Do what?
It's drawn as it's above, but wouldn't the 9/16 be a little bit higher and actually include it?
You're right. You're right. And the reason is the height of R4, or of R3, 1, 2, 3, the height of R3 is what? 1/2. And I should have used this. Let me get that off of there for just a minute. What we found is that this point right here, that point, is that, right?
Yes.
Hmm?
Yes.
But that's not what we want, is it? Our R3 is length times width, huh? But the length is 1/4, but the height or the width of it is 1/4 plus 1/4, which is 1/2. Follow what I'm saying? Everybody? Everybody?
Like all three different tires though. I guess it's going off the left.
Do what?
I was right from earlier from the 9/16. So that's what I was asking. Why is it in the?
That's right. I apologize to you. See, what I would have done, the way I originally had it, I would have had a rectangle from here down. And that was your point all along, wasn't it? And the reason I kept arguing with you about that is because I was talking about a rectangle from here down. Okay? But now you're probably prepared to agree with me that that is error right there.
Yes.
Everybody agree?
Yes.
Okay? So I'm going to put my dot back.
Okay.
Not that it matters that much, but it does matter that you get the right length and height, huh? Okay? All right? So, this is then 1/64 plus 1/16 plus 1/8 plus 1/4. Everybody agree? And I think this is then 4 64s. Do you think that? This is then 8 64s. And this is 16 64s. That look right to you? Everybody? So that is 12, 13, and 16. Is that 29 64s? Okay. And what we did, do you agree what we did is cut down there? Now what I would do, and I don't know, I might do it in a minute, but at least for now I'm not going to do it. Then I would do it from the other side, right? Like we did on the first one. And instead of all of this goes together. And then what I would do is I would That's exactly right. Now what I would do is, now I'm going to do them from the left-hand side. So what I'm going to do is I'm going to make this rectangle that's R1. Then this rectangle is going to be, this rectangle is going to be R2 right here. This rectangle is going to be R3 right here. And this rectangle is going to be R4 right there. Do you agree? Everybody agree? Okay. And doesn't that then put the error, doesn't that put the error right here? Everybody? And there is a little bit of error. Do a better job. I want you to notice is, in the first one that we did, all of the error, almost all of the error, was up here, making it too high. And over here, all of the error is beneath the curve, making it too low. So if I found this, wouldn't I then find the lower bound for it? And I would do just like I did a minute ago. I would say that the real error is between the error on the high side and the error on the low side, and the difference between the two is less than it was before. But it's still not good enough. So what do you do? What do you do?
Please don't say make no rectangles.
Make 8 rectangles instead of 4. Make 8 rectangles instead of 4. We're not going to do it, but we are going to draw it.
What class is that? Or was that on the midterm?
No, that was the one that we went over in class. It took like the whole class.
But in order to make 8 rectangles,
Did you have that class next?
in order to make 8 rectangles, don't I need to do
Sort of 3 straight lines.
Do you agree? And this one to be convincing needs to go to the right a little bit. For the most part, I know they're not exact, but isn't that pretty good?
Mm-hmm. Better than I can do.
So, what is the width of every rectangle?
116.
Right.
Is it 1/8?
Yeah.
Everybody agree? Isn't this length from here to here 1?
Yeah.
And didn't I divide it into 1, 2, 3, 4, 5, 6, 7, 8 parts? So wouldn't that make it be 1/8? Everybody okay with that? So now, all I need to do is find the lengths, huh? And let's draw some rectangles, and that is, here is R1, here is R2, here is R3, here is R4, here is R5, here is R6. Notice at R6, I've got some that are both above and below. Wait a minute.
Wouldn't it be
Um,
up higher or is it up top?
Here is, yes. Here. And then here. And then here. And then,
You don't need the next one.
yeah, that's right. Right? Is that right? So now, notice what our error looks like. That's not good. But isn't that a huge improvement? Isn't that a huge improvement from where we started? That's way too much error. That's way too much error. So now what are you gonna do? I'm gonna make 16. But guess what? 16 doesn't suit me either. So then what am I gonna do? I'm gonna make 32 of them. But 32 doesn't suit me either. Do you get the idea? And you can make it as accurate as you want to by doing what? And adding as many rectangles as you need to.
Won't you infinitely still have an error?
Yes, absolutely you will. Absolutely you'll still have an error, but you can make that error as small as you want it to be if you're willing to put up with the pain that goes with it. And the pain is in the, well, I can't say that on camera where that pain is, but I expect you can guess where the pain is. Do you agree? Okay, everybody agree?
Yeah.
Okay. Now, there's one more thing you can do to improve your hand. And that is this. I want you to notice what happens here. I'm going to go back to 4 rectangles, okay? Because I don't want to have to draw all that up. No. This is 4 rectangles. I'm going to use the midpoint now. You know, we've been using the left end and the right end, huh? I'm going to switch up here. I'm going to switch to the midpoint. Okay? Watch what happens now. I'm going to go to the, what looks like the midpoint of each rectangle. And I'm going to make a rectangle right there. And is that the rectangle? I don't like coloring that in. Is that R1 right there? Okay, now I'm going to go to what looks like the midpoint right here. And I'm going to make, is that R2? You agree? Yeah. Now I'm going to go to what looks like the midpoint right here. And is that R3? And I'm going to go to what looks like the midpoint up here. And is that R4? Everybody agree?
If you say so.
Do what?
If you say so.
All I did was I found the midpoint. Now what I want you to tell me is, I want you to tell me what the coordinates of that point are.
All the way across.
1/8?
1/8, 164.
64th, 8 times 8. You have the right idea.
Back to Russia.
1/8,
Can we send you back to Russia?
1/64.
I don't like your
Does
fact.
everybody agree? Everybody agree? All right, I want to know what the coordinates of that midpoint are.
3/8.
3/8 and
3/8,
Shut your
9/16. Is that right?
9/64.
What direction?
9. Same dog bit me. 9/64. Jonathan talked me into that a minute ago. Is that right? Spencer, you asked the question a minute ago, so I'm gonna get you to explain it now. Where did the 9/64 come from?
It's,
I put the X value of 3/8 into the equation of the curve, didn't I? Is that right? Everybody agree? And how about this one?
Five eighths. 25/64.
This is, if this is a fourth, and it is, isn't it? If this is a fourth, then this is 1, 2, 3, 4, 5, 6, 6 eighths. Do you follow what I did? 1, 2, 3, 4, 5 eighths. 5 eighths. Do you follow what I did? So this is 5 eighths. Exactly. 25/64. Everybody agree? And this one, this point is what?
7/8.
That's 7/8 and 49/64. You get the idea? And now can't you just multiply length times width and get the exact area if you want to? But here's what I would rather you notice. What I want you to notice is this. We now have two kinds of error. We now have two kinds of error. And that is, I have the top error, which is this, 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 this. Do you agree? Let's see. Yeah.
Yeah.
Yeah, I got it right. I have the top error, huh? So the purple is top error. Do you follow the name I gave it, top error? Isn't that the area on top of the red line, but below the blue rectangle? In the blue rectangle, huh? Now, but we're also going to have some bottom error.
Yes.
And I'm going to start here. Is that bottom error?
Yes.
And the reason I started there is because it would have been hard to point to this. Isn't there a little bit of bottom error there? And then there's bottom error here. And then there's bottom error there. Right?
That looks like it evens out.
What?
That looks like it evens out.
Exactly. Exactly. That's my point, Spencer. Very good. Thank you. It doesn't. You can't assume that it does. But doesn't it look like the top arrow, the purple, is an estimate that's too big. The bottom error, the green, is an estimate that's too small. But just looking at the graph, don't the two almost offset each other? Trust me, they don't. They don't. You can't count on that. But do you see that using the midpoint greatly improves things? Because instead of all of the error being in one direction, at least you've got it offsetting, haven't you? Okay? So let me go back over here and write some things so when you see it after a while. And that is the green.